So we made a correction on these first two problems and we multiplied them out using box problems, and we got the answer in standard form. This answer right here is called standard form, where you have the x squared first, and then you have the x, and then you have the 35. What we are going to be working on this week is taking this form and changing it back into the factored form. We are working on undoing the box problem. And so, as I told you last week, we're working at this one little skill at a time. First, we did the box problem skill, or foil if you prefer. And then we did factoring out the GCF. And now we're going to do factoring by grouping. And what we're working toward next week, after we get all this factoring done, is actually taking the factored form and solving it. But you can't take the factored form and solve it until you know how to get to the factored form. And so we have set up a step-by-step process in order to help you get to the factored form. Now, the first thing you do is you look at the problem and you factor out the GCF. What does GCF stand for? Greatest common factor. So my numbers are 3, 6, 4, and 8. Does that have a greatest common factor other than 1? What? If it was just the 6, 4, and 8, it would have a greatest common factor of 2. But once we threw the 3 in there, the only greatest common factor is 1. If I factor out 1, I get the same thing. Do they all have an x? Does the last one have an x? It does not. This one does not have a GCF. Now, in this box number 2, step 2, what do you see that I have done? Where did I get that? I just copied the same problem down again. So you copy the same problem down again, and you make 2 groups of 2. I am going to make 2 groups of 2 because I don't have a GCF for the whole thing, but I'm going to look for the GCF on just this part. Does this part right here have a GCF? Both of these will divide by 3, and then both of those will divide by x squared. Does this part right here have a GCF? Then I am going to factor out those GCFs. So, for this part right here, I'm going to factor out the 3x squared. 3 divided by 3 cancels out. X to the third divided by x is simply an x. 6 divided by 3 is 2, and the x squareds will cancel out. For this term right here, I'm going to factor out a positive 4. 4 divided by 4 cancels out, and I have an x. 8 divided by 4 is 2. Do you notice something about this strangely factored thing? What do you notice about this right there? The common binomial is x plus 2. Both of them have an x plus 2. I am going to factor out an x plus 2. Now here's where it gets a little shaky because our factoring skills are not that great. If I factor an x plus 2 out of this part right here, what's left? This x plus 2 I factored out in front. What's left? That is completely factored. Over here in this box, I'm going to use this to check it out. How can I check it out? Well, I have an x plus 2 and a 3x squared plus 4. If I multiply that together, is this the original problem? If you multiply these two together, you get the original problem back. I have factored this into that. And then, again, what's coming later after we get down this factoring is then taking this and actually solving for x. But not yet. Example number 2. Look at the numbers 6, 3, 4, and 2. Is there a GCF number? Is there a GCF variable? Do they all have an x? So we write the original problem down and make 2 groups of 2. Looking at each group, is there something that factors out of this group right here? Is there something that factors out of this group right here? Looking at just this part right here, when I factor out a 3x squared, 6 divided by 3 is 2, and x to the third divided by x squared is just x. What's 3 divided by 3? Jonathan, you need to stay up. Looking at the second factor, when I factor that out, this is a positive 2 I am factoring out. 4 divided by 2 is 2x. 2 divided by 2 is 1. Do you see something that's written down twice? That is written down twice. That is going to factor out of both terms. That's the GCF for both of these terms. If I factor this out, the 3x squared is left. If I factor this out in front, the plus 2 is left. This term and this term go together to make the second term of your factoring. Helpful hint. If the first term in the group is negative, factor out a negative. I cannot factor when I start with a negative. It can be done, but it just messes my brain up. So, when this leading coefficient is negative, why would that be called a leading coefficient? What the first one out in front is called a leading coefficient. If the leading coefficient is negative, then you need to factor out a negative 1. So when I factor out a negative 1, I factored out a negative 1 because it's a lot easier to factor if this leading term is positive. So I have this negative 1 out in front, and then I have 2x to the third plus 15x squared plus 16x plus 20. Do you know why these are plus signs and not minus signs? Somebody in my previous class was confused about that. When you factor out a negative, it's going to change all of the signs. Now, I'm going to make two groups of 2. Just leaving the negative 1. He's just going to hang around in front all the way till the last step. 12 and 15. What factors out of 12 and 15? 3x squared, because they both have at least an x squared or bigger. What factors out of 16 and 20? Okay, this negative 1 is just hanging around out there in front. When I factor out a 3x squared, 12 divided by 3 is 4. X to the third divided by x squared would just make an x. 15 divided by 3 is 5. And the x squareds are cancel out. I'm just going to keep writing through this next square because I don't have enough room to fit it all in there. And so this is going to be a positive 4 I'm going to factor out. 16 divided by 4 is 4. 20 divided by 4 is 5. Do you see something in common? This term and this term. Now the negative 1 is still hanging around out in front. He hadn't dropped off of the problem. The 4x plus 5 is down there twice. The 4x plus 5 is multiplied by 3x squared. The 4x plus 5 is multiplied by positive 4. That is factored. Once again, what we're going to do next is then take that factored form and solve. So I'm going to take my x to the third plus x minus 5x squared minus 5, and I'm going to make two groups of 2. And what am I going to factor out of this group? Can I factor out an x squared like I have done on the previous problems? This is just an x, so I can't factor out an x squared. What am I going to factor out of these two? Now, this is very important. If this sign right here is a negative, you must factor out a negative or it's not going to work out right in the next step. If this sign right here is a negative sign, you must factor out a negative. When I factor this x out, that's going to be x squared plus what? What's x divided by x? Anything divided by itself is 1. I'm going to factor out a negative 5. 5 divided by 5 is going to cancel out. What's negative 5 divided by another negative 5? What do I see in common? So I'm going to factor out the x squared plus 1. This x and this negative 5 become the second term. If you used your box problem, multiplied that out, you would get the original problem back. So this is number 1 on your homework paper. I look at all 4 terms. I don't have a GCF. What is step number 2? Make 2 groups of 2. Now, what is the next step? Look at this group. What's the GCF for this group? What's the GCF for this group? So then we're going to factor out the 5x squared out of this group. 25 divided by 5 is 5. X to the third divided by x is x. 5x squared divided by another 5x squared is 1. When I factor a 4 out of this group, 20 divided by 4 is 5, and it has an x. 4 divided by 4 is 1. What do you notice? Do you see that both terms have a 5x plus 1? The second term comes from this 5x squared and this plus 4. That makes the second term. Example number 2 on your homework paper. First thing is to look for a GCF. If that minus 2 wasn't down there on the end, you could factor 7 out of everything, but that does not have a GCF. 2 groups of 2. This is what a guy did in a previous class period, and it didn't match. What do I mean it didn't match? Does this term match that term? If those two terms don't match, one of two things happen. Either in this step right here, you didn't use the GCF, or it's not factorable. So, in this case, the problem was right here, this is not the GCF for these two numbers. What should I factor out of these two numbers? 7 divides into both of those. So if I divide out a 7, this is going to be 7x plus 2. And let me remind you, if this is a negative number, this needs to be a negative number. And there is always a factor. If nothing else will factor, then 1 will factor. And so when I factor out a negative, now when I factor out the GCFs, then do these two terms match? 7x plus 2, and this is 7x squared minus 1. This term and this term go together for your second binomial. So if you get to this step right here and you don't find anything that matches, go back to the previous step and check it out and see if there was something that you factored incorrectly. Please complete problem number 3. What happened there? You're not completing problem number 3 for me.